This is a video solution for torque worksheet problem number 3. Already see I've got a beam drawn, I've got the tension on the right, I've got the reaction force, and I've got 3 downward forces for the electrician, the weight of the board, and the weight of the light bulb. So here's my basic strategy. I'm going to sum up all the forces in the x and y direction, and then what I'm going to do is I'm going to use torque to figure out the unknown forces. And I'm going to pick a location for an axis of rotation where there's an unknown force. So I'll pick it around either left or the right where I don't know the variables. I'll start with the free body diagram. It's pretty simple. I'm going to have a tension, a reaction force, and all the forces going down. It's kind of an abbreviated free body diagram, and I've done this because I just don't have space on the screen to do what I want it to do. Now, with my reaction force, I'm not going to leave it as R. Instead, what I'm going to do is I'm going to break it up into components. So you can see how I've drawn this little triangle where R is the hypotenuse, and I'll have a horizontal and vertical force. And I'll put those at the base where R is located. So there'll be a V and an H. We'll call the forces V and H. Nice and simple. I'm going to do the same thing for tension, except I'm not going to relabel it. Instead, I'm going to use some trig, and I'll get a vertical component for tension. That's T sine 60 and T cosine 60. So now all my forces are perpendicular to each other, and that's what I want when I'm going to be summing up the torques. So let's sum up the torques. We'll sum up the torques about the left end. Notice the notation. I've got a rotation symbol with a positive sign. I've got the summation symbol. I've got the Greek letter tau and a subscript that tells me where the torque, the axis of rotation, is located. You're going to need to put all those things down when you write this out. And all that equals 0 because it's not rotating or not accelerating. And when I look at this, if I use the left end, here's why I chose the left end. Excuse me. There are 3 forces that I don't know. There's V, H, and T. So I'm going to pick an axis of rotation where I don't know the forces. So I can put it in the left end or the right end. If I put it at the left end, V and H will not appear in my torque equation. If I put it in the right end, T will not appear in my torque equation. Well, I want to get rid of 2 variables instead of 1 variable, so I'm going to put it at the left end to get rid of V and H at the same time. So that's why I summed up the torques the way I did. So I use V and H as my pivot point, and my negative and positive signs in the equation, they come from the way that it causes the beam to rotate around the axis of rotation. Not because of the direction of the forces per se, but it's about the direction of the rotation, because these are negative and positive torques, not forces. And then I'll simplify it a little bit, and I get my tension to be 342.56 newtons. So that's 1 out of 3 variables. That's great. Now for the other variable, there are a couple things I can do. I could find some of the torques around the right end and use that. But instead, what I'm going to do is I'm going to sum up the forces in the x direction. So H minus T cosine 60 is equal to 0. And then if I do that, because of the value I just found for T, I can then find the horizontal force to be 171 newtons. Also, because I know the T, if I sum up the forces in the y direction, you can see how I have it all summed up with all the components. You can also see that I have a new free body diagram with just components on it, and I get my vertical force to be 683 newtons. For the next part of the problem, it said how far out did the electrician walk if the tension was 900 newtons. So for this part of the problem, I ignore the tension I got in the previous section, and now I'm going to make it 900. And my unknown variable is x, and that's the distance that the electrician walks out. So to figure this out, I'm going to have to sum up the torques, because summing up forces doesn't tell me anything about distances. So I'm going to sum up the torques again about the left end. So this is the same equation I had before, except what I'm doing is my tension is now replaced with 900 newtons, and x is the distance the electrician walks out. So instead of it being 3 meters, I've got to figure out what that distance actually is. So then when I solve this for x, I get the x to be 5.14 meters.